Alright, so for part A, we were trying to find the rate of change at time 0. So we're going to pull both of the rates that it gives us. It gives us the birth rate and the death rate. Birth rate is going to be 1000 E T, and then the death rate is 250 E to the T. So when things are birthed, it is a positive, and then when they die, it takes away. So that's going to be negative. So these are already rates, so we don't have to like find the derivative. So really it's just going to be the birth rate minus the death rate. That'll give you the total rate, and it wants it at time 0. So that really just comes down to 1000 minus 250, which is 750, and it is frog per year. Yeah, so that's going to be part A. It's pretty
Today we're going to be going over the C1 FRQ part B, which is asking to the nearest whole number, what is the average rate of change of the frog population on the island for time 0 to 50? So this is asking for average rate of change, which we know is the average value theorem, which is going to be 1 over b minus a, the integral from a to b of the function d of x. So we already know that the rate of change is b of t minus d of t, and since it's asking for the time from 0 years to 50 years, it's going to be 1 over 50 minus 0, with the integral from 0 to 50, b of t minus d of t dt. And you plug this into your calculator with the original two equations, the birth rate and the death rate, subtracted from each other. And you get negative 1008.812, which you round up to the nearest whole number. It's negative 1009 frogs per year.
Hello, this is Cole Bernstein here for an FRQ practice problem, C1 letter C. So, the question is, what is the absolute min and absolute max amount of frogs on an island from years 0 through 50, and with the addition of there being 110,000 frogs on the island at year 0. So we are given two equations. The birth rate, b of t, which is equals to 1000 e.06 t, and then the death rate, which is 250 e.1 t. Thus, the rate of change equation can be surmised to be the birth rate minus the death rate. Now, with absolute min and absolute max problems, it's important to remember, usually we'd find the derivative and then set it equal to 0, solve for t or whatever variable, and that would be your critical number. However, in this case, these two equations are rate of change, so finding the derivative of them would be incorrect. This is very important to look out for. So we set it equal to 0, and since it is a calculator approved problem, we find that the critical number, the t value, is 34.657. So there are three values we have to check out, because remember, we have to check out the n values for absolute min and max problems, and then this will be the number. So okay, the next step, now that we have the x values we have to test, is creating an equation to figure out the total amount of frogs on the island at any given time. Thus, we take the starting number of frogs and then add it with the integral, 0 to t, of the rate of change. Because this is the rate of change, not the amount of frogs. Thus we have to go a step back and almost find the area underneath the slope. And thus we take the integral. So then, since this is a calculator approved question, we just plug in, it's obvious that 0 would obviously be under 10,000 because, 110,000, my apologies, because obviously the integral of something 0 to 0 is 0. And then for 34, we have 149,166.6 repeating. So sorry, my handwriting isn't too good. And then 50, we have 59,559. So the max frog, and I'm writing in shorthand for the sake of space. I do not recommend doing this. I recommend writing it out in full and complete sentences, just to be safe. It's all about being safe on the AP exam. And then obviously we wouldn't include any decimal. You could either chop around, and the absolute min frog population is 59,000. That's it. So yeah, I hope you enjoyed that, and good luck on the AP exam all.
Okay, so for Frq C1 letter D, is the rate of change the number of frogs on the island increasing or decreasing when t equals 30? So we have the birth rate defined as b of t equals 1000 e to the 0.06 t, and we have the death rate defined as d of t equals 250 e to the 0.1 t. And so in order to find if the rate of change in the number of frogs is increasing or decreasing when t equals 30, we have to do the derivative of the birth rate minus the derivative of the death rate, because the derivative is the rate of change and we're trying to find if the rate of change is increasing or decreasing. So be it as the rate of change is increasing or decreasing. Some people might think it's birth rate minus death rate. That gets you, birth rate is not derivative, just birth rate minus death rate, but that gets you number is increasing or decreasing. The number of frogs is increasing or decreasing. We're looking for the rate of change is increasing or decreasing of the frogs. So now you can use your calculator, because you're allowed to use your calculator on this FRQ. And for Y1, we want to put our B of T, so 1000 to second e to the 0.06 x or t, and then we have for d of t 250 the second e to the 0.1 x, and then for y3 we want to do 1000 to the second 0.06 x, and then that minus the d of t, which is 250 second e 0.1x. Okay, so now that you have that, do second quit. Actually, go back, put those parentheses there. Okay, second quit, and then go to math 8, and then put d over dx alpha. Alpha F4, and you go up click Y3, plug in this as 30, we get negative 139.1596. So we have, so first we do math 8 and then you want to plug in so for 2 plug in d over dx y3, because we plugged in y3 already our formulas, or you could just skip that and you can just plug in b prime minus d prime of 30. Either or is fine, and x equals 30, not 8, which this gets you b prime of 30 minus d prime of 30 equals negative 139.1597. So the rate of change in the number of frogs on the island is decreasing at t equals 30 because, or since, b prime of 30 minus d prime of 30 is less than 0. And that is your final answer.